Yeah, and thank you to the conference organizers. I think this is just it's been a great conference. We don't. I was talking to folks at lunch. I don't remember the last time I saw this kind of cross connect between industries. I think it's really great. So really appreciate y'all opening it up industry wide. It's already been worth it even before the chance to speak. So thank you. Yeah, and as Richard mentioned, going to talk about messaging gateways. There's been a lot of we're messaging people, and so I think a lot of here. We've already covered a lot of the key ideas of what it is, so we'll blow through that pretty quickly. But want to talk about just in our experience of implementing some pretty large gateways, and then also kind of cross connecting it with just the end user base, like what the enterprise, developer and operation teams, what the makeup that whole ecosystem looks like, and how we can build upon what has been done in the past. So the idea here isn't to blow up everything and make something new, but start taking another iterative step and really help enterprises and organizations move their platforms forward, and also share some of the things that we've done in the platforms that we've implemented. Again, a lot of this is going to be about reducing human touch points. A lot self-service is really everything these days, and things of that nature. So go quickly. You guys know what a messaging gateway? In short, it's really just an ability to move messages between physical locations. Kind of the easiest way to think about it. We just had a great presentation there from Mateo. Talked about connecting cars. The use case I'm going to speak on is really more the retail, or like a retail endpoint, or something would be like vending machines. Something that's more like fixed physical locations. The main benefit is that applications that are using a gateway don't need to handle all the problems that come with inconsistent network performance and availability, or maintaining how to connect to servers. Sam talked about early. Developers have to, and he kind of breezed over like the error handling, the retry, but that's kind of everything really anymore when we're dealing with distributed systems. And when you centralize your applications across physical locations using a gateway, you're reducing the amount of code that developers are responsible, and the errors and things that they've got to handle. You're taking a ton off their plate. And so you're going to provide a lot more consistency. Things will be handled all in the same way. And you're really taking a lot of code off their plate that they'd have to work with. Because in the Hello World sales demo of sending a message down to a store, it's maybe a half a dozen lines. When you start adding retry, configuration, error handling, that all of a sudden that balloons out to much larger. And the savings is really massive. It's really, and I see it rarely quantified, is really just this idea of, hey, let's create some data highways and allow application teams have a nice code repository of this is how you send, this is how you get, this is how you handle the failover, the retry, and then let everybody kind of multiply and get that organizational velocity, which is one layer up above kind of the team sprint layer. This is me. Apache ActiveMQ PMC member. JB did a good job talking about what we're doing in the project. So a lot of what we work on is with ActiveMQ. I'm leading a lot of the observability, migration modernization. We just, I think JB's kicking the release out. The next 6.2.0 release includes the virtual thread support, which is really exciting. Historically, I've done a lot of work in hybrid messaging. So I've migrated a little over 10,000 IBM MQ queue managers. I've also done a lot of work with permanent hybrid, IBMQ, ActiveMQ, several other vendors. I got my start in the early SOA days. So yeah, he remembers. And the way it worked, and I kind of have an interesting, I think, background that I started really in open source first, through high school and college. Got out into the enterprise. I was working for a mid-size telecommunication company, and we knew we needed to do an API platform, which back then was called SOA, with messaging. And we had to do the bake-off between the top 3 products. And so, of course, we went through, ranked them, gave that to management, said, hey, we feel really good about number 1, like price, capability, it's going to do everything we need. Number 2, kind of expensive, a couple whistles and bells, but we could do without it. Number 3, we're like, don't touch it. Like, please, God, no. Like, we can't do option 3. So, of course, what did we go with? Option 3. There was supposed to be some sort of dealing between the companies. They needed some internet access. Of course, that didn't happen. So me and my team were stuck with option 3 that literally didn't work. And so that's really how I got into adopting some of these open source technologies. And so we were out there digging around in the early days of Mule and ActiveMQ and Service Mix to find like please something that we can deal with, and that's how I got into it. So I think it brings kind of an interesting perspective, kind of being on the enterprise side first. So we've always kind of carried that with us, and how we attack things is thinking about how does this impact the people developing and managing to it. It's great to be in a room with really bright people. But a lot of times, and we're seeing trends with developers where, a developer in an enterprise might be in the seat for only 2 years, right? An ops team member, maybe a year and a half. So if we're thinking about having these really complex systems do really cool and awesome things, it's like, how do we make it easier? How do we make it easier to comprehend, easier to manage, easier to run? And really gain confidence in the we want to gain organizational confidence, and that we might solve all the technical problems, but if we don't solve the people problems, they're not going to be able to realize that. So a lot of this shift, the idea here of shifting concepts of what we've done in the past is, really now gateways really must provide more of everything. So all the technology, all the security, performance, capabilities, but it really needs to require less from DevOps and messaging platform operation teams. And that's kind of a contradicting goal, but I feel like it's the reality of what we've done in the organization. So some of the concepts with what we call our Gateway 3 architecture is we've really noticed that moving more towards choreography over orchestration. So instead of having like big clusters that know about everything that's going on, we want to build as many like kind of individual operating with as least number of runtime dependencies as possible. We're still retaining a lot of key elements of store and forward. There's a lot of really great things out of 30-year-old architectures. Every time I think we've kind of seen the end, to go back and look at some old architectures from 25, 30 years ago, it's like, aha, that's why they did that. But we want to do things to really help developers, get out of, I think what were policies that are a little too permissive. So we want to layer on like things that are stricter policies about what can get sent into the platform. There was conversations about messaging schema. I think we could take that a step further. Obviously, self-service must be there. And more observability. This takes that load off the operation teams, put it in the hands of the developers, which enables them. We're not trying to throw it over the fence, but we're trying to shorten that latency, that support latency. And if we can give them a common set of tools and documentation, example code, then the developer teams can be more self-sustaining. I think what Matteo just talked about was, what they did with the virtual topics in MQTT and Pulsar is very similar to the transmission queue concept in IBM MQ. And then we apply that same concept in this in ActiveMQ. So, not every queue needs to be have all the same characteristics, and it can be used differently, as he showed. We also introduced the concept of a batch queue and routing queues, which other products have similar things. And we want to focus on developer automation experience and the developer experience. And then just kind of a key thing here is, the solution for handling back pressure for multi-threaded producers. It starts looking like a whole broker really quickly. So if you've got to send multiple producing threads and you want to make that highly reliable and handle the back pressure, pretty soon you're going to start taking compensating actions like we're going to page this to disk, or we're going to throw an error, we're going to back. All of a sudden, everything you look on that producer side starts looking like a broker. And really, this gateway architecture becomes a core building block to the broker mesh. And as JB mentioned in his ActiveMQ talk, one of the key things ActiveMQ has is this VM transport. And a second capability of that is you can code an app. It could be like a REST endpoint. You're receiving data from third party, and then you want to write it to a queue. You can have a URI in your app where you start off deploying that endpoint that talks to a broker over another network. Well, just by flipping the URI, I can make an embedded broker run in that service and forward the data to another cluster of brokers. So we can do some really cool things, which is really more of like a broker mesh. And so this concept of what's out on the edge or what the leaf nodes, they don't always need to look like a server. They don't always need look like a whole broker. We kind of have these like micro or mini brokers that are running inside existing applications that may have originally just been written to be producers. We'll be sharing more information and examples on that kind of later, but just wanted to talk through kind of the building block and where this kind of leads. Quick gateway architecture, yay, we've got a cloud. one or two apps, this could get into the hundreds or thousands, but we need to handle the routing and, network mediation between physical locations. This starts, getting wider. We really like doing partitions over big wide clusters that know everything. This allows for gradual upgrades, rollbacks. If you get, some things that can happen in a physical, when you're deploying to physical environments, is you can have large natural disasters, fiber cuts, hurricanes, and you can lose whole swaths of nodes, not just the single node failure. And so when you have broker architectures like this, you can shuffle that traffic around and handle, kind of big events. There's a lot of focus on like single node and single element failure, but there's times you can get the cascading, as I mentioned. And so when you get to kind of broker 3 or gateway 3 architecture, we talk about having a routing layer on the top. This is about managing and mediating. When you're sending to 5 or 10,000 physical endpoints and you've got a dozen application, the number of destinations really explodes. And so this is really about making steps to move from a large number of inbound connections to a small number of queues, then from a small number of queues to a large number of connections. So by leveraging different queue types, so the top layer we'd be using what we call like a routing queue, and the middle layer we'd be using a transmission queue. By kind of changing that architecture and by making hops, we enable the ability to kind of manage that challenge, which message brokers spend tons of time on, which is numbers of connections, numbers of destinations, things like that, numbers of threads. So batch queues, this is pretty cool. We needed to solve a problem where it kind of came out, and ActiveMQ's got a couple features that allow us to do this. So one of the challenges you have is if you want to run a large number of messages related to like a pricing data set, and you don't want it to be released until it's all loaded. So this is what a batch queue does. So it's a one-time use queue. The messages get loaded up. Once the message group is closed, then the messages will flow down. So the messages are never forwarded down if the batch isn't completely loaded to the first hop. And then this queue would be garbage collected when done or expired. And so this is the kind of the mindset here is think cattle versus pets for your queues. So we don't need these queues to always be long living, right? If we're doing a pricing data set, one of the cool things this allows us to do is we can still get the effectiveness of a large transaction with, excuse me. We can get the effectiveness of a large transaction, but still using asynchronous sends, which is kind of counterintuitive. But since no messages would be delivered to the next hop, it waits till it's all closed. So we fast load everything, and then once it's closed, we know we've received everything. Then messages start moving to the next layer. And so it looks like a large transaction. You can overcome, max commit counts. You don't have to have the latency with transactions. You get async send, and with ActiveMQ, when you turn all the async flags on, you start getting like stream-like performance, which is really useful. There's other key use cases for like one-time use queues, specifically like large, long-running scheduled tasks. So if you have a CI job, you want to take a single message off a queue, but you're building a piece of software that takes 30 or 45 minutes. You want to keep that message in a transaction. You can't have that consumer open for that long, or it starts looking like a slow consumer. And so by using these one-time use patterns, we can still get the reliable delivery, the transacted semantics, the individual processing, but overcome some of these things that become contradictory to each other that we run into in messaging like all the time. So batch queues have been a key fun part for this. So with message routing, in previous iterations of gateways, there's a lot of static addresses and maps, or you may even kind of what I call Gen 2. There was a lot of like camel or mule integration. A lot of the problems with that we found is organizations struggle with code upkeep. So if you're an operations team and they're doing, their DevOps team, their coding time is typically spent in automation around deployments, monitoring, alerting, scaling, and getting into languages and frameworks becomes a challenge, and finding resources for that. And so we want to have kind of more things built in. Platform teams need fewer parts, right? Like less things to know about, just make it work. So they can scale and increase velocity. So we like to look at a metric like how many ops team people do you have versus the number of brokers, and then how many developers, like how many services can they support. And so we think those are good metrics to help guide organizations with. So the shift would be, in routing, this isn't new, but we want to do routing without additional disk writes. We want to have abstract client-coded addresses from the actual queues, broker names, and topology. Also the ability to support like per tenant routing maps and then self-service of those routing maps. So if you've got an application and they want to, they're moving things to stores and they want to, and we're pushing things through different routing and transmission queues, and when they get to the end, they want to fan out. Day one, they might have one queue for their app, and then they want to be able to use different message properties. So we'd want them to be able to update their maps. Once they've kind of tied into the platform, they should be able to add, within reason, the ability for their messages to kind of train, or them to add like a new flow kind of thing. Platform policies. I think this has really been a big challenge. The dead letter queue problem becomes, I think, a bigger conversation when we get into like application development, where we typically talk about errors in a way of like, we'll just retry, but there's a lot of errors that we already know up front that are never going to get better. If you send a JPEG of the funny cat meme and a consumer's expecting JSON, that's never going to work. We don't need to do redeliveries. We don't need to do retry. It doesn't need to be looked at in a dead letter queue. So I really want to think about, in dead letter queues, it's kind of I think there was kind of the mindset of, hey, we want to be cool admins. We're going to let you send whatever you want, and you got this place to go manage it. And we're being as platform managers, we're being very like accommodating, but it's a little too accommodating, because then it actually puts more work on the developers to have these jobs to do all these things. So it requires constant monitoring, rework, and all this stuff. You guys get it. So we want to have this concept of a dead letter queue and a retry letter queue. So we already know there's a whole set of things that can get fixed with a retry, and there's a whole bunch of things that can't. So if you're dead, just be dead. Like, we don't want to redeliver. We don't want to retry. Like, you're dead. And we might put you in a dead letter queue because it may be unexpected, and you can get alert about it. Or it could be in a dead letter queue, and it could quickly expire and just go away. On the policies, we want to be in the past, we were very permissive in receiving messages. We want to really increase this. Like, if there's header requirements, if there's a message type, if there's, we don't allow you to use priority, we require you to use, these other capabilities. We want to, like, you're not connected with failover. Really reject early, like at the per tenant level. So before they even send anything, the developer is going to be like, nope, you're not using the failover protocol. You can't talk to us. Or you connected a producer to the consumer-only transport connector. You're not able to do that. So there's a lot of things that we can do to really increase that immediate feedback to developers about things that would cause their application problems. On the dead letter queue, as I mentioned, we want to only DLQ things that are really dead. And then we've got this concept of a retry letter queue. A retry letter queue is cool because if you move everything is retryable, it can be automatically replayed. And some things will go and some things may not, but that's fine. But it makes an automatable way to handle that error and fallout. And again, the whole goal here is to provide that immediate feedback to developers, and DevOps have kind of established their processes. This enforces it at technical. In the past, it's been things like there's a wiki page, or there's an example config somewhere, and everyone's supposed to just know, put this in your URI to make it compliant to our platform. So we want to really do more enforcement. As I mentioned, I started out open source, then I went enterprise, then I went services, then now I'm doing more product. And so I've kind of always carried that enterprise hat with us, which is kind of a contradiction. And I think, but we try to be open and transparent, just share. I think it allows us to kind of connect with our customers and say, hey, yeah, we've been in your seat. I think for customers, I think if they have to constantly re-platform, it's a major disruption. And there's, confidence gaps in the industry. So I really like the things I was hearing, from Richard and conversations about, standardizations, things that we could do to make the experience better for enterprises just as a whole. Ideally, if we had, more or refresh on standardizations, APIs, and protocols, the real uplift in any enterprise isn't changing the deployed brokers, right? It's the app code. It's the cost of having to change the 5,000 to 10,000 apps that most modern enterprises have these days. And so the more we drive towards that, I think it's just a better deal for the industry. And being, coming from the enterprise seat, that'd be something like I'd be wanting. So that's something that we share with our enterprises. Like, hey, you guys have a say in this. You're part of the ecosystem. Y'all should demand this. Control sort. Well, we'll skip over that for now. Yeah, the last thing, just really application code should not change when topology or product provider change. That's really the expensive part. You can move providers, you can move cloud vendors, but if you got to go change the code, that's really where the pain is, and really the cost and the impact to the business. And so we try to encourage customers to think about it this way: that the company with the lowest cost to deliver change will win their segment. So if they've got really expensive platforms or their cost of change is high, they're going to struggle, and their competitors will have an advantage. We're seeing some struggles with streaming, like at the gateway layer. For example, a change in a message retention policy at the broker level is kind of a change in the original contract, which the app was coded. So if an app was coded with a 14-day retention policy, and then costs are high, and management comes down and say, finance is like, hey, we're now doing 3-day. Well, if you app coded to something with a much higher retention, like that's, there's a conflict there. The same message is rarely going to every endpoint anymore. Like if you're sending the price of toothpaste, that's changing by region, by store. So you're typically doing a lot of like really kind of targeted messaging. Batch queues are really valuable because these don't deliver if there's an error in the batch. And so this can be preferable over constantly redelivering the same data. So this batch queue concept is, we've seen as being very fruitful in this. Just another way to think about queues. Queues are really great for moving data. Like we're talking a lot about API and app integration, but if we're really just moving it, queues are excellent for that. And then the idea of retaining tons of messages that don't ever get replayed. Like we just see a lot of effort in like replication and replaying and all these things, and like a lot of this stuff never actually happens, and so there's this big cost. And so I think we're starting to see conversations about which workloads work best and which kind of platforms. So I want to put together just a couple quick wins. One of the questions we get is, hey, should we put a broker in the store or the physical location, like a distribution center? And the answer is yes, absolutely. Get good at it. The number of apps and devices in physical locations is only going to continue to grow as the demand for automation, integration, robotics, AI, all these things. So it's in your benefit to get good at being able to put things where you're doing critical business usage. The other thing is, from physical location going straight to the cloud, that's a big hop, right? The number of layers in between. It's not one network link, right? If you're in, and you're connecting up to a cloud provider in Chicago, and you're out in, Missouri or North Carolina, that's a lot of network links. I'm in the telco world. I'll tell you, there's a lot of Perl still there. There's a lot of duct tape. Like, the network works, but there's just a lot of layers, right? And, one of the things that when people ask us, well, where do we put the broker? And the answer we always tell them is put it as close to your app on all ends as you can. So same physical location, same Kubernetes cluster, sometimes same pod, same process. But the closer you put the broker to the producer and then closer to the consumer, that's where you're going to get the benefit of doing messaging. As soon as those hops go longer, you're starting to lose some of the win, which is that the ability to manage all the network changes. The mindset of partitions, not one big cluster. This term partition, we're really talking about is segmenting traffic, not one big cluster. So that I'd probably go back to that earlier word, choreography. So we kind of design a system where these nodes can talk to these endpoints by themselves. They don't need any other third-party dependencies. They're not talking to a cluster controller. There is an operator in configuration automation that's being pushed or pulled, but the brokers themselves can run with that, a lot of times without a load balancer. Again, going with the idea that when there's less things in the stack, there's less security patches, there's less updates, there's less downtime, there's less interruption to the apps. I definitely recommend security early. It's very hard to add later. In our experiences, once dev teams kind of get their arms around two-way SSL, they'll share it with others. I think the best way that we've seen communicating like how to do hard things is get one app dev team, figure out how to do it, and they're going to do the work for you. They'll go tell the other app teams once they have success with it. And two-way SSL solves all the problems. I think the jump to tokens, creates that other third-party dependency. We've seen some challenges with that, trying to plug into like OAuth systems. Back-end data processing and OAuth wasn't really designed for it. It can be done. I think there's a halfway with it. But if you just go all the way to two-way SSL, you kind of solve a lot of other problems as well. Monitoring cost is a real concern. We're talking thousands of endpoints, each with dozens and thousands of queues. Keeping that time series data is really expensive. An alternative to that is using health checks. So just monitor the health checks that come back for those nodes. At the end of the day, if your gateway's flowing and the data is being processed, if the health checks pass on the store endpoint and you kind of monitor the flow with the brokers, you don't need to have time series data of every queue, every endpoint for all of time. So yeah. And then also, if a broker support cost is a factor, you might have a wrong vendor. There's definitely alternative ways to get to implement and do these things in a really cost-effective manner. This kind of going back to number one. I think one of the things we hear is the cost, like licensing costs, things like that can be expensive, and so we just really want to encourage, definitely you want to get brokers close to where you're doing the work. Lastly, I added this slide after some of the conversations. We had a lot of really good conversations. I think, in our experience, one of the things that's really been a challenge in messaging adoption is there's not like a curl for messaging. With REST and API integration and the challenges, and Sam spoke on those earlier today, that app teams have with all the threads trying to handle their own retry and connectivity and errors and security and logging, all this stuff, microservices. But at the end of the day, one of the things that makes that stuff really attractive is you've got really simple tools that everybody knows how to use. You can get a REST endpoint. You can post a payload, and an admin, and Unix ops guy can do it. Somebody in a Kubernetes pod can do it. curl's just installed everywhere, and we don't really have an equivalent of that on messaging. And so, I guess really my kind of challenge, just us as an industry, would be, hey, we can do this. The OpenSSL has already provided a pattern, right? It supports multiple protocols, multiple algorithms. We could do something similar with a set of command tools. So yeah. Anyway, appreciate you guys having me. Any questions? All right. Excellent. Got it in time. Thank you very much. Oh, coffee's next. Right. Sorry. Oh, I didn't mean to steal your thunder.
I've got one job.
Oh, sorry.
One job.